morning, everyone, and welcome to the material session. My name is Zehavit Reisin, and I'm managing the material business for Europe and Asia. It's my pleasure to be here today and introduce everything about our new materials. But before we start, what is the role of 3D printing materials? The role of 3D printing materials is actually to meet the requirements of the three most important applications. Prototyping. This is when we simulate the look, feel, and function of the end part. Here the materials should have dimensional stability, sometimes colors, sometimes it's a rigid end part, sometimes it's a rubber one. When it comes to tooling, we talk about durability. We talk about lightweight replacement for metal, for example, and sometimes static dissipation and ESD performance. And obviously, manufacturing, the name of the game here, from material perspective, would be to get the exact performance of end-use parts. With us are two plastics technologies. Polyjet technologies, which you all know, inkjet-based with acrylic-based photopolymers that enable the fine details and smooth surfaces. The beauty, I would say. It also enables jetting of simultaneous modeling materials, and that opens a wide range of opportunities in color, in transition from rigid to rubber, from transparent to opaque. And then, next to it is our FDM solution, FDM technology with thermoplastics materials that can take us from standard ABS all the way to high performance Ultem 1010 at 203 degrees heat resistance. What happens when we combine the life cycle of rapid prototyping that Tomer just discussed with you, as well as manufacturing with the requirements for end-use part performance, consistency, and repeatability with those two technologies? It's clear that when we get into design verification, where accuracy and fine details and the colors matters, Polyjet technology will shine. And when it gets into resistance to pressure, resistance to temperature, resistance to chemicals, all that will be with FDM technology that takes us into functional performance, tooling, as well as end-use parts. And let me take you to Polyjet design with new materials. And all in one print click on our J series. And if that's not enough, we simplified the whole communication of designers that wanted to print now with my eyes color. How do I describe that? But if we have Pantone PMS 1503, that's much clearer, right? And that's exactly what we did when we signed the agreement with Pantone. Here it comes. The design and the part realism is educating us all how to do it with Stratasys solution. And today with the J850 and J835, we are launching the part realism, the productivity, and all at a reduced cost. So Tomer already discussed with us the concept design with the draft gray. What is this draft gray material? Ladies and gentlemen, the well-known Vero gray that you all use intensively. It's one of the top materials used in Korea. This is now our draft gray. And you cannot tell the difference when it comes in 55 micron lengths. This is the quality that we bring you at super high speed. Double the speed, half the price. For detailed design, I think it's you that came to me and told me, Zehavit, Vero Clear is not clear enough. Sometimes in bulk part, it's a bit grayish. Okay, we took your comments seriously, and we are launching today Ultra Clear. Ultra Clear is a digital material made of two components. A component which is Ultra Clear surrounded by Vero Clear. This enables us complete simulation of PMMA, glass-like appearance, and you can see the result that the transmission percentage is now 86% in Ultra Clear versus 70%, 75% in Vero Clear. Typical use cases would be, yes, just transparent single models, but how about transparent VRML made of two shells, where the inner one is image texture and the outer one is set to transparency at 100%. And of course, transparent assembly. The final design, I wanted to highlight that other than the fact that we have now cyan, magenta, yellow, black, white, and then the two ultra clears, we also have the possibility, without to replace the resin, to have digital ABS, to have Agilus, and to have Vero Ultra Clear, all on the same part, on the same tray. No waste, and it's all about cost saving. In sum, the J850 portfolio of materials: for concept, Vero Draft Gray; for detailed design, rigid materials, rubber-like, and even functional ones as digital ABS. And in the detailed and final design, we have the ultra clear with the vivid colors. So far for PolyJet. Let us move to RP engineering this time with our FDM technology. Today, we are adding two new revolutionary materials on our F370. And the idea is to enable more tooling use cases. The first one would be the first nylon material on F-Series. And the second one would be the well-known ABS ESD7, which you know from Photos line, now on F370. So ladies and gentlemen, I'm very pleased to introduce the RAN. This is the nylon-based materials filled with minerals that is all about formulation that withstand the rigorous demands of the factory floor. What is the problem we are trying to solve here? The problem is that traditional jigs and fixtures are heavy, they are expensive, they are limited in functionality, and more than often they damage sensitive parts by marking paint and finish. With the RAN, which is a nylon-based material filled with mineral, we are able to gain high lubricity, meaning low surface friction, low scratch, and hence there is limiting damage to parts that are in contact with those jigs and fixtures. Not less important is the fact that it comes with a pillable support, straightforward, breakable, and pillable. The use cases obviously would be processing aids and different production aids. ABS ESD7, low-cost material that enables ESD performance. The problem we are trying to solve is the usual one with electrostatic discharge that can very often degrade or even destroy electrical circuits. Sometimes equipment malfunctions are just a result of static shock, and production parts are usually, from traditional methods, very heavy and costly. ABS ESD7 is basically made of carbon nanotubes that are blended into our ABS material. It's now available on F370 and comes as well with soluble support. Primary use cases would be protective electronic devices that enables the ESD safe performance. Last but not least is manufacturing with FDM. Today we are introducing the Antero ESD version. I'm holding here a part of a program of NASA, which I will talk about in a minute. The problem we try to solve here is the same problem with Antero, meaning that production parts through traditional methods are very costly and heavy, and also fixtures tend to degrade when in contact with chemicals. But the third issue is, of course, that static buildup actually can create sensitive electronics to be damaged, and this is what we are solving with Antero ESD. So ladies and gentlemen, once again, PEC-based material with carbon nanotubes to enable ESD performance, yet with the same properties of Antero, HDT of 150 degrees, exceptional chemical resistance, and strength that is even larger than Ultem, 93 megapascal. This is the program I talked about, the NASA Orion spacecraft, and what I'm holding here is a printed docking hatch that met all the requirements we just talked about, from dimensional stability all the way to ESD performance. In sum, the materials are the segue to everything you want to do, from prototyping, and we talked today about concept verification with draft gray. We talked about the design cycle with the ultra clear, and engineering with the entire F123 set of materials. In tooling, we introduced on F370 the DRAN, the first nylon-based material on F-Series, and ABS ESD7. And we concluded with manufacturing, mainly for aerospace and later automotive, with Antero family and the new member, Antero ESD. Ladies and gentlemen, I welcome you to make it exceptional with Stratasys Materials and Solution. 감사합니다.
감사합니다.